Okay, the objective for this next lesson is to be able to find the prime factorization of a composite number. And so basically there's two methods that I'm going to teach you how to do this. I'll teach you doing a factor tree. That's the way that most people have learned, I think. And the other way is there's actually many different names for it. Cake method, the ladder method. I even saw it called the slide method. I'll just show you that. And for my purposes, since I'm used to calling it the cake method, that's what I'll call it. But let me first show you what the factor tree looks like for those of you that forget and need a reminder. We remember factors are numbers that multiply with other factors to get the number, or what numbers multiply with each other to get the number that we're factoring. So maybe the best way is to show an example, and let's see the factors. This is not prime factorization yet, but I'm just showing you what factors look like. The factors of 12 are 1 times 12, right? And 2 times 6, and 3 times 4, and then I already said 2 times 6, and 1 times 12. So those are factors. But we can see from those factors that they're not all prime numbers. We can see 4 is not prime, 6 is not prime, and 12 is not prime. So prime factorization is a little different. We want to know what are all of the numbers that we can multiply, the prime numbers that we can multiply together to get 12. So one is we can multiply 2 times 2 times 3. All of those are prime numbers, and 2 is a prime number, other 2 is obviously a prime number, and 3 is a prime number. 2 times 2 is 4, 4 times 3 is 12. So that would be the prime factorization. So let me show you the two methods of how to get that. Let's say we wanted to find the prime factors, or the prime factorization of the number 36. Well, if you want to do a factor tree method, basically you'll see what times what is going to give you 36. I always like to start with 2 if it's an even number, because that's the smallest and easiest. So 2 times what is 36? Well, that's 2 times 18. Now, 2 is prime, so we leave that alone. And let's move to 18. What times what equals 18? Since it's an even number again, let's do 2 times 9. 2 times 9. Now we can see 2 times 2 is 4. 4 times 9 is 36. However, this is prime, this is prime, this is not prime. So what number times what is 9? Well, that's 3 times 3. So in the end, we have 2 times 2 times 3 times 3 equals 36. And that's the prime factorization for this, for the number 36. All prime numbers, when you multiply them out, they get 36. Then if you want to check it again, 2 times 2 is 4. 4 times 3 is 4 times 3. Well, 12 obviously, right? And 12 times 3 is 36. So that would be the tree method for factoring, getting the prime factorization of 36. Let's try, how about the number 30? Well, again, we can do 2 because it's even, so 2 times 15, and the factors of 15 are 3 times 5. So the prime factorization of 30 is 2 times 3 times 5 gives us 30, all prime numbers. Okay, let's try one more with the tree, the factor tree. And then we'll move on. Let's see, let's do the number 56. Okay, even, so we're going to do 2 times 28. Now, actually, I'm going to back up. Instead of doing it this way, can anybody think of a number, two numbers that multiply together to get 56? Because this is another way to do it. And those of us that know our multiplication tables rather well, we know that 7 times 8 is 56. So this is another way of doing it if you didn't start with 2. I just want to show you it one time. Now, what times what is 8? Well, that's 2 times 4. And then 4 can break down into 2 times 2. So here we have again, and typically when we do list these, we do list them from least to greatest. So we'll write 2 times 2 times 2 times 7 equals 56. And this will be the prime factorization for that, for 56. Okay, now that was called the factor tree, the tree method, and I want to show you the other method that I like to use. Again, I guess it's called many different names, ladder, or I call it the cake method, but doesn't matter. Let's try. Here we'll start with from the bottom. Okay, and it looks a little funny with only one number, but when you start to use finding the greatest common factor between two numbers, then I think this method will prove to be a little easier. So if you look at the factor tree and you go, oh, I think that's easier, just still keep in mind this cake method or this ladder method, because you might find it easier once we get to greatest common factors in a second. So let's see. 24, what can be multiplied into 24? Well, that's 2 times 12, and we'll put that up here, and you'll see how we climb as we go along. Okay, and then the reason why it's called cake is because sometimes it looks like cake here. It doesn't matter. 12, what can we factor out of 12? We can factor out a 2 out of 12. Then we have a 6. And then we can factor out another 2. And we have a 3 remaining. So this is how 24, if we take out a 2, we're left with 12. If we take out a 2, we're left with 6. If we take out a 2, we're left with 3. And that's going to be the top. So that's 2 times 2 times 2 times 3 is the prime factorization of 24. Now let's try one more. How about 70? Well, what can we take out of 70? We can take a 2 out of 70, and we're left with 35. You can see as we're taking things out, it gets smaller and smaller, right? Let's see, can we take a 2 out of 35? I don't think so. Can we take a 3 out of 35? I don't think we can take a 3 either. How about a 5? Let's take 5 out, and we're left with a remainder of 7. So the prime factorization of 70 is 2 times 5 times 7. And again, we can really easily double check that. 2 times 5 is 10, 10 times 7 is 70. And I do recommend that you double check those. Okay, last one we'll do with this method is 66. Okay, let me draw a line here so you don't get mixed up. We'll factor out a 2, and we're left with 33. Okay, then I don't think we can factor out a 2, but we can factor out a 3, and we're left with 11. So 2 times 3 times 11. And 2 times 3 is 6, and 6 times 11 is 66. So here again is here's the prime factorization for that one. Okay, so the prime factorization means you're trying to find all prime factors. When you multiply all those prime numbers together, you get the original number that you're trying to factor. Okay, so that'll be it for this lesson, and see you on the next video.